This is my trigonometry course. Today we're going to do some geometry review and learn the 6 basic trigonometric functions. Let's first review the triangle sum theorem. We learned this in my geometry course. The theorem says that the angle measures in any triangle always add up to 180 degrees. And of course we're talking about the interior angles. So let's do a couple practice problems real quick. This is just basic review, so we're not going to spend a lot of time on this. All these angles, 88, 55, and x, they must add up to 180 degrees. Why is that? Well, because it's a triangle. So 88 plus 55 is 143. Subtract 143 from both sides of the equation, and the angle measure is 37 degrees. Let's try number 2. We see here that we have a box there, and what does that mean? It means that the measure of that angle is 90 degrees. I'm just going to draw that box a little better. So 90 plus 50 plus y is equal to 180. 90 plus 50 is 140. Subtract 140 from both sides, and the angle measure must be 40 degrees. So let's do one more of these problems before you try one on your own. Again, the triangle sum theorem tells us that the measures of the interior angles in a triangle must add up to 180. Y plus y plus y is 3y. Divide both sides by 3 and we get 60 degrees. So you can take a screenshot of this if you want to use this. Well, I'll just leave it in the window. Go ahead and try number 4. Find x, and when you come back we'll do it together. Okay, we're back. So again, the triangle sum theorem tells us that the sum of all the interior angles in any triangle add up to 180 degrees. So 30 plus 135 is 165. Subtract 165 from both sides and we get 15 degrees. So if you got that one right, good job. Okay, remember, a box means that this angle is, the measure is 90 degrees. So go ahead and try number 5, and when you come back, we'll do it together. Okay, we're back. So again, the sum of all the interior angles in any triangle is equal to 180. So we're going to simplify the equation and isolate z, and we get 30 degrees. So if you got 30 degrees, excellent. Good job. Go ahead and try number 6, and when you come back, we'll do it together. Okay, we're back. So if you add up all these angle measures, you should get 180 degrees because it's a triangle. That's the way it always works. If you add x and x, you get 2x. Subtract 30 from both sides, and we get 150. Divide both sides by 2, and we see that x is equal to 75 degrees. So if you got that one right, perfect. Okay, so we went over the definition of trigonometry. We gave an introduction in the first class of this course, so I don't really need to go over this again, but remember, trigonometry is the study of the relationship between the angles and the sides of triangles. And that's where these basic trigonometric functions come in. We studied these three functions in my geometry course, but we're going to add three more, and these 6 trigonometric functions are going to be the foundation of this entire course. Each of these functions gives a relation between the sides and the angles of a right triangle. And it's important to understand that these functions are only defined for right triangles. They're used to help us study other types of triangles, but when it comes to these functions alone, they're only defined for right triangles. Now, notice these little symbols here. Those are Greek symbols. That's the theta symbol. And you're going to learn various Greek letters: alpha, beta, theta, omega. A lot of different Greek symbols are used for angle measures. And this is a right triangle. Obviously, this angle here, its measures 90 degrees because it's a box. And if we call this angle theta, then the side opposite that angle is this side here. The side adjacent is this side. And this side is also adjacent, but we don't call it adjacent, the side adjacent to this angle. We call it the hypotenuse. It has a special name. The longest side of a right triangle is called the hypotenuse. It's always the side that's opposite the right angle. And the reason that this yellow side is called the opposite side is because it's not part of the angle theta. Now, you might be thinking to yourself, well, wait a second, what about this angle up here? Doesn't that angle matter? Well, it does matter, but all you need to know to determine the shape of the triangle, and therefore the ratios of the sides, is this angle. Because we're assuming that this angle is a right angle, and once you determine this angle, the second angle, then the third angle is immediately determined. It's set in stone. For example, if this angle is 50 degrees, then we know immediately that this angle must be 40 degrees because of the triangle sum theorem, which says that the 3 angle measures of any triangle must always add up to 180 degrees. So if we know that this angle measures 90 and this angle measures is 50, then the only way that the angle measures can add up to 180 degrees is if this angle measure is 40 degrees. So once you determine what theta is going to be, the shape of the triangle is set. And as I said, once the shape of the triangle is set, it doesn't matter how big or small the triangle is, the ratio of the opposite side and the hypotenuse is going to be the same. You could have a triangle the size of the planet Jupiter, or you could have a triangle the size of a fly. The ratio of the opposite side and the hypotenuse is going to be the same because the shape of the triangle is the same. The angles in the triangle are the same. Now, you might notice that that's not exactly easy to take in, that whole concept. This is one of the most difficult things in the math curriculum. That's the bad news. The good news is that all you have to do is memorize these 6 basic functions, the definitions, and learn how to find these ratios, and that's going to be really, really easy to do. So this may seem very, very intimidating, but do not be intimidated by this stuff. As we go along, you're going to understand more and more about this. Trigonometry is actually not very difficult. It looks really, really difficult, and the concepts can be difficult, but using the trigonometry is actually pretty easy, as you're going to find. So let's say that we choose this angle. Again, this angle is always 90 degrees. Let's say that this angle is theta, then sine theta is defined as the length of the opposite side to that angle divided by the length of the hypotenuse. And cosine theta is defined to be the side adjacent to that angle, that length, divided by the length of the hypotenuse, and so on and so forth. You might wonder why these functions are defined to be ratios of the sides of the triangle. The reason is, as I just mentioned, the ratios are going to be the same no matter how big or small the triangle is. Once you plug in this theta value, the shape of the triangle is set, and the ratios of the sides, in this case opposite over hypotenuse, is going to be the same no matter how big or small the triangle is. So that's the benefit of defining these functions as quotients rather than products. Now again, this is all very, very complicated stuff, as you can see. But again, there's no reason to be intimidated, because all you need to know in the beginning part of this course is how to find these values, and you're going to find that that's very easy. Students have a tendency to hate these functions with a passion because, well, there's many reasons. One reason is these are forms of function. This is a function notation. You plug in an input, in this case theta, and your output is sine theta. That's very confusing. Function notation does tend to be a little confusing. The second reason that students typically don't like these functions is, in many cases, in fact, in the real world, in engineering and science, most of the time when you calculate these values, you have to use a computer, because these functions require advanced mathematics to compute. So students are forced to use a calculator to come up with these values, and that adds a lot of mystery to these functions, and students don't like mystery when it comes to mathematics. Another reason that students get confused with these functions is that they don't understand why this angle is put into the function, that angle measure, but we don't really seem to care about this angle. But I just explained a little bit about why that is. Keep in mind that theta could be up here, and that would make this angle dependent on this upper angle. It doesn't really matter where you plug in theta. But if theta were up here, if we chose to erase this theta value and put it up here, then the opposite side would be this side. This side would be opposite of theta, and this side would be adjacent. So it wouldn't really change anything. It would just make our diagram, the reference, the relation of the sides to the angle, it would make them different. Now, you're probably looking at these thinking, well, this is going to be very difficult to memorize. How am I going to memorize all these functions? Well, we already learned a method to memorize the first three functions. If you forgot, that's okay. You're going to use these functions so many times in this course that you couldn't forget them even if you wanted to. So it's not really something you have to worry about. And that's really the purpose of today's lesson, is to make sure that you have these memorized, along with some other things. Now, remember in my geometry course we learned SOHCAHTOA. SOHCAHTOA helps us remember these first three functions. So let's review this. SOHCAHTOA. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So SOHCAHTOA. You can use that if it helps you. So go ahead and get a screenshot of these 6 basic trigonometric functions, because we're going to use these as we work along in the class today. But I'm going to drag these with us in case you don't have them right in front of you. And I just want to say one more time, don't be intimidated by these functions. If you don't understand everything that we just talked about, you're in good company, because 99.9% of students don't fully understand. In fact, pretty much 100% of students don't fully understand these functions when you first see them. Over time, your understanding of these functions is going to increase. But now we just need to learn the definitions of these functions. And as time goes by, like I said, your understanding will increase. So let's get started with some practice problems. So notice that I have brought these functions with us over here. If you forget, you can look up there. We have a triangle. You see this triangle over here. In fact, I'm going to make that triangle red so we can differentiate. And it says find the values below. So that means these green values. We have to find these green values. All of these values. So we first need to find sine A. So what does that mean? It means we look at the angle A, and this triangle is the angles are defined are named after the names of the vertices of the triangle. We go up to sine here, and sine is the opposite side over the hypotenuse. Now the hypotenuse is 39 because the hypotenuse is always the opposite side of the right angle, the 90-degree angle. Remember, we call angles with measures of 90, we call them right angles. But the longest side is always the hypotenuse. That's how you can determine the hypotenuse. So we plugged in a hypotenuse here, you see. And now we need to find the opposite side. The opposite side of angle A. So here's angle A, this green angle. The opposite side is not this this purple side. That's the adjacent side. And it's not this pink side. The pink side is the hypotenuse. The opposite side is the side all the way over here. That's what opposite means. So the opposite side is the side that is not part of the actual angle that we're talking about. So the opposite side of A is 15. Now I'm going to divide both sides by 3, and we get 5 over 13, and that's the answer that we're looking for. Sine A is 5 over 13. And I want you to reduce these fractions if you can. Now cosine A is defined as the adjacent side divided by the hypotenuse. So again, the hypotenuse is 39, we know that. And the adjacent side is, well, there's two adjacent sides to angle A. Both of those purple sides are adjacent to angle A. But this side is not referred to as the adjacent side, even though it is adjacent. It's referred to as the hypotenuse. The adjacent side is 36. So now we're going to divide both sides of that fraction by 3, and we get 12 over 13. So as you can see, this is pretty easy stuff. The difficult thing is to memorize these functions, and that's what you're going to do today, along with some other things. Tangent A is the opposite side, which we already found is 15. The side opposite A is 15. So the opposite side divided by the adjacent side. Now again, 39 is adjacent to A, but it's not called the adjacent side. It's called the hypotenuse. So this side is the adjacent side. So divide both sides by 3, and we get 5 over 12. All right. So now we're going to find sine B. We already found sine A. Sine A was 5 over 13. But now we're looking for sine B. That's different from sine A in this example. So again, sine is opposite over hypotenuse. But now we're talking about angle B, so we have to look at angle B. The side opposite angle B is not this side. That's part of the angle. And it's not this side. The opposite side of angle B is this side. That's not part of the angle. So opposite over hypotenuse. The hypotenuse doesn't change. Divide both sides by 3 and we get 12 over 13. Cosine B is adjacent over the hypotenuse. Now again, we're talking about angle B. There are two adjacent sides to angle B. There's the hypotenuse and there's this side. But again, the hypotenuse is not considered, it's not called an adjacent side, even though it is adjacent. This side is the adjacent side. So 15 over 39. Divide both sides by 3 and we get 5 over 13. Okay, so let's bring our functions down. So again, we're just getting used to these functions. You're going to need these functions in math analysis, pre-calculus, calculus, and you're just going to be using them thousands and thousands of times throughout your math education. So I know that these are kind of weird, but you're going to get used to these as we go along, so don't worry. Tangent B is opposite over adjacent. Now I've rewritten the triangle down here so we don't have to scroll up. So look at angle B. The opposite side is again 36 and the adjacent side is not 39. 39 is adjacent, but it's not called the adjacent side. Whoops. Tangent is opposite over adjacent. Divide both sides by 3, we get 12 over 5. Cosecant A. So now we're changing to angle A. So be very aware when you're changing to a different angle. Now cosecant, this is the first time where we're using cosecant in my curriculum. So students who took my geometry course, you haven't seen this yet, but that's okay. Cosecant is defined to be the hypotenuse divided by the opposite side. So the hypotenuse is 39, and what is the opposite side of A? This side and this side are adjacent sides to A, but the opposite side is 15. That's the length. Divide both sides by 3 and we get 13 over 5. This is the first time that we're seeing secant in my my curriculum. So we're going to find the secant of the angle A. Secant is defined to be the hypotenuse divided by the adjacent side. So the side adjacent to A is 36. It's not 39, it's 36. 39 is adjacent, but we don't call it the adjacent side. Cotangent A is defined to be the adjacent side divided by the opposite side. So the side adjacent to A is 36 and the opposite side is 15. So divide both sides by 3 and we get 12 over 5. Okay, so let's do a few more here. Now we're switching to angle B. Again, it's the same triangle, I just rewrote the triangle. Switching to angle B. Let me drag our functions along with us. So you can see these in front of you. So look at angle B. We're now focusing on angle B. Cosecant is the hypotenuse divided by the opposite side of B, which is 36. And that reduces to 13 over 12. Secant B is the hypotenuse divided by the adjacent side. The adjacent side of B is 15. Divide both sides by 3 and we get 13 over 5. And cotangent, that's defined to be the adjacent side divided by the opposite side. So the adjacent side to B is 15 and the opposite side is 36. Divide both sides by 3 and we get 5 over 12. Okay, so let's do one more of these problems, and I'm going to go a little bit faster here now that you're starting to get the idea. But we do have a root, a square root. So we're going to have to be careful. In some of these problems, we may have to rationalize the denominator. So sine A is defined to be the opposite side of A divided by the hypotenuse. And now we have to rationalize the denominator. We're not allowed to keep a root in the denominator. So I'm going to multiply both sides by root 5. 1 times root 5 is root 5. And remember, in my intermediate algebra course, we learned that the nth root of A times the nth root of B is equal to the nth root of the product of A and B. So when you multiply these, we get the square root of 5 times 5, which is 25. So I combine these to this green here. Now, what is the square root of 25? What number times itself is equal to 25? What number multiplied by itself is equal to 25? The answer is 5. So we rationalize the denominator. I'm going to throw this up, and maybe I'll change that to a blue color so we can remember that. Cosine is the adjacent side, which the adjacent side of angle A is 2, divided by the hypotenuse. Now we have to multiply both sides by root 5 to rationalize the denominator. 2 times root 5 is 2 root 5, and root 5 times root 5 is root 25. And of course, the square root of 25 is 5. So there is no root in the denominator anymore. So that was the whole point of that. Now tangent A is defined to be the opposite side of A divided by the adjacent side. So we're done with that one. That one was pretty easy. Again, I'm getting all this from these functions here. Sine B, now we're changing to a different angle. Sine B is the opposite side of B. The opposite side of B is 2, divided by the hypotenuse, which is root 5. So now we're going to have to, again, rationalize the denominator, but I think you understand how to do that. So I'm not going to bore you by showing you those steps again. Multiply both sides by root 5. In the bottom you get root 25, and root 25 is 5. So now we need to find the cosine of the angle B. Cosine is defined as the adjacent side divided by the hypotenuse. The adjacent side of B is 1. Multiply both sides of the fraction by root 5, and we get root 5 over 5. Okay, so I'm going to bring these formulas up again. And we're still on problem number 8. So now we need to find the tangent of the angle. Tangent is the opposite side divided by the adjacent. So that's 2. Opposite side of angle B is 2. The adjacent is 1. And now we're switching to angle A. Cosecant is defined as the hypotenuse. Whoops. The hypotenuse divided by the opposite side of A. Opposite side of A is 1. So that answers root 5. Secant is defined to be the hypotenuse divided by the adjacent side of angle A, which is 2. And cotangent is defined to be the adjacent side of angle A divided by the opposite side. So cotangent of the angle A is 2. And now we're going to find the cosecant of angle B. Let me get my list of functions. So now we're moving to angle B. Cosecant is the hypotenuse divided by the opposite side of angle B, which is 2. And we don't have to rationalize the denominator because it's already rationalized. There's no root. Secant is defined to be the hypotenuse divided by the adjacent side of angle B, which is 1. And cotangent is defined to be the adjacent side of B divided by the opposite side of angle B. Okay, so now it's time for you to try. You can take a screenshot of these problems that we just did if you'd like. You don't have to, but you can get a screenshot of these. And I'm going to bring these functions down for you so that you can see them. Try problem number 9, at least the first 4 or so functions, and when you come back we'll do it together. Okay, we're back. So sine is the opposite side of A divided by the hypotenuse. How do I know that? Well, because it says it right up here. Opposite side divided by hypotenuse. So all we have to do is reduce that fraction and we get 4 over 5. So if you got that one right, excellent. Cosine A is the adjacent side of A divided by the hypotenuse, which reduces to 3 over 5. If you got that right, perfect. Good job. Tangent A is the opposite side divided by the adjacent side, which reduces to 4 over 3. If you got that right, good. And now we're moving to a different angle. Sine is opposite over hypotenuse. The opposite side of angle B is 6 and the hypotenuse is 10. That reduces to 3/5. So if you got those right, perfect. So now I have rewritten the triangle down here. That purple triangle, I rewrote it. Okay, go ahead and try these problems. We're still on problem number 9. Try those green problems, and when you come back, we'll do it together. Alright, we're back. Cosine B is the adjacent side of B divided by the hypotenuse, which reduces to 4 over 5. Tangent B is defined to be the opposite side of B divided by the adjacent side, which reduces to 3/4. Cosecant A is defined to be the hypotenuse divided by the opposite side of angle A, which is 8, and that reduces to 5 over 4. And secant A is defined to be the hypotenuse divided by the adjacent side of A, the side adjacent to A. So that's going to be 6. Reduce and we get 5 over 3. If you got those right, good job. And we have a little bit left to do for problem number 9. Go ahead and try these last 4 problems, and when you come back, we'll do it together. Okay, we're back. Cotangent is defined to be the adjacent side of A divided by the opposite side, which reduces to 3/4. Cosecant B is defined to be the hypotenuse divided by the opposite side of angle B, which is 6, and that reduces to 5 over 3. Secant B is defined to be the hypotenuse divided by the adjacent side, the side adjacent to B, which is 8. That reduces to 5 over 4. And cotangent B is defined to be the side adjacent of B divided by the opposite side, and that reduces to 4 over 3. So if you got those right, excellent. But now we're going to have to deal with rationalizing denominators. So I want you to try these first 4 problems. Find these first 4 expressions for problem number 10, and when you come back, we'll do it together. Okay, we're back. Sine is defined to be the opposite side to angle A divided by the hypotenuse. So it looks like we didn't have to deal with the root on that one. Cosine A is defined to be the side adjacent to angle A divided by the hypotenuse. We have a root there, but we didn't have to rationalize the denominator because it's already rationalized. There's no root in the denominator. Tangent A is defined to be the opposite side of A, which is 3, divided by the adjacent side. Now we have a problem because we have a root, a radical, in the denominator. So I am going to multiply both sides of this fraction by root 7. And remember, we learned those rules. When you're multiplying roots, as long as the index is the same, the index on both of these, remember, is 2. If you can't see an index, that always means it's 2. So the index is the same. I meant to highlight these two here because we're combining these two. So 3 times root 7, we can just write that as 3 root 7. But root 7 times root 7 is root 49. And the reason that's useful to us is because the square root of 49, well, you tell me, what number multiplied by itself is equal to 49? What number multiplied by itself is equal to 49? If you said 7, then you're correct. So we rationalize the denominator. So if you got that one right, perfect. Okay, sine B is defined to be the opposite side of B, which is root 7, over the hypotenuse, which is 4. So if you got that one right, good. Alright, so we're still on number 10. Let's do the rest of number 10. Go ahead and try to do all these problems that you can see in the window. And notice that I brought the triangle with us so we can see it. Try these problems, and when you come back, we'll do them together. Alright, we're back. Cosine B is defined to be the side adjacent to B divided by the hypotenuse. Tangent B is the opposite side of B divided by the adjacent side. Cosecant A is the hypotenuse divided by the side opposite A. Secant A is the hypotenuse divided by the side adjacent to A, and that presents a problem because now we have an irrational denominator. So we have to multiply both sides of that fraction by root 7. So I'm multiplying both sides of the fraction by root 7, and we get 4 root 7 over root 49. The square root of 49 is 7, and there you go. So if you got that one right, good. Now cotangent is defined to be the adjacent side of A, which is root 7, divided by the opposite side. And there you go. So if you got those right, perfect. So we're still on this problem. Let's finish up this problem. Go ahead and try these last three, or find these last three values. When you come back, we'll do it together. Okay, we're back. Cosecant B is the hypotenuse divided by the opposite side of B, which is root 7. Rationalize the denominator, and we get 4 root 7 over 7. So I don't want to bore you by showing you how to rationalize denominators over and over again, because you probably remember that from intermediate algebra. Secant B is the hypotenuse divided by the side adjacent to B. Cotangent B is defined to be the adjacent side of B divided by the opposite side. And we have a problem we have to rationalize. Multiply both sides of the fraction by root 7, and we get 3 root 7 over 7. So if you got those right, perfect. So again, the whole purpose of this is to memorize these functions and get used to the different versions of these types of problems. And we're also reviewing how to rationalize denominators and a number of different things. So if you already know some of this trigonometry, that's okay. We're going to get to more difficult stuff probably in the next class. Now, in the previous problems, we named the corners of the triangle, the vertices, with letters, and we named the angles of the triangles by the same name that we gave the corners of the triangle. But in this situation, we're actually given letters that represent the actual angle measures. But it's pretty much the same situation. It's really no different. And typically you'll see Greek letters used for angles, but sometimes you'll see other things. So let's find sine omega. Sine is the opposite side of omega divided by the hypotenuse. Now we can reduce this fraction. If we divide both sides by 2, we get 2 root 2 over 3. Cosine omega is the adjacent side to omega divided by the hypotenuse, reduce, and we get 1/3. Tangent omega is the opposite side to omega, opposite side of omega, divided by the adjacent side. 4 divided by 2 is 2. So we're not only reviewing the sine, cosine, and tangent functions that we learned in geometry, but we're also introducing these new functions, and we're reviewing how to reduce fractions and to rationalize the denominator. So we're doing a lot of things all at once. So I want you to try these two problems here. So go ahead and try these green problems, and when you come back, we'll do them together. Okay, we're back. Sine beta is opposite over hypotenuse. So the opposite side divided by the hypotenuse, and that reduces to 1/3. Cosine beta is the side adjacent to beta, which is 4√2, divided by the hypotenuse, which is 6. Divide both sides by 2, and we get 2√2 over 3. So if you got those right, perfect. Okay, let's try this next problem together. Tangent beta is defined to be the opposite side of beta divided by the adjacent side. So the opposite side of beta is 2, and the adjacent side is 4√2. Now these cancel, and you get 1/2, but the √2 doesn't go anywhere. A lot of students will have problems converting this form to this form, and that's one of the reasons that we're doing these problems, is you need to get used to the correct way to find or to write these values. Now we have another problem. Not only do we have to reduce the fraction, but we also have to rationalize it. We're not allowed to have a square root in the denominator. So what do you think we should do? Well, if you said multiply both sides by √2, you're correct. 1 times √2 is √2. √2 times √2 is √4. Now, how do we find the square root of 4? Well, we simply ask ourselves, what number times itself is equal to 4? And the answer is 2. So this expression here became 2. And now all we have to do is just multiply. 2 times 2 is 4. And we have our final answer, which is √2 over 4. So that was a more involved problem. Now let's find cosecant omega. That's going to be the hypotenuse divided by the side opposite of omega, which is 4√2. So this is very similar to the previous problem. Let's first reduce. We can divide both sides by 2, and we get 3/2√2. And then we're going to multiply both sides of the fraction by the square root of 2. And we get 3√2 over 2 times √4. And the square root of 4 we found in the problem above. That's just equal to 2. And let me see if I can find more room here. And then in the bottom, 2 times 2 is 4. So there you go. Okay. So I want you to try. You can take a screenshot of these if you'd like to use those to help you. And I want you to try all of these problems that you see in the window. all these green problems. And when you come back, we'll do it together. Okay, we're back. Secant is defined to be the hypotenuse of the triangle divided by the side that is adjacent to omega, which is 2. So that would just be 3. Cotangent is defined to be the adjacent side of omega divided by the opposite side, which is 4 root 2. 2 divided by 4, that reduces to 1 over 2. And then we have to rationalize the denominator. And I don't want to bore you by doing the same math over and over again. So I'm just going to do that in my head. And you don't have to show the work. You can do it in your head too if you want to. So we're going to get root 2 over 4. So if you got that one right, perfect. Now cosine beta, that's defined to be the hypotenuse of the right triangle. Again, all these functions, they only refer to right triangles. It's the hypotenuse divided by the side opposite beta, which is 2. And that reduces to 3. So if you got that, good job. Secant beta is the hypotenuse divided by the side that's adjacent to beta, which is 4 root 2. If you divide both sides by 2, we get 3 over 2 root 2. Multiply both sides by root 2, and we get 3 root 2 over 4. Again, I did most of that in my head, but if you're able to do that, you don't have to show the work. Okay. One more of these problems. Cotangent beta is defined to be the side adjacent to beta divided by the side opposite to beta. 4 divided by 2 is 2. And there you go. So I divided these and they became 2. So if you got those right, excellent. Okay, so now we have a different triangle. Let's be sure to bring down our functions. Sine theta is the side opposite theta, which is 3 root 5 divided by the hypotenuse. And I would like you to do the rest of the problems. So go ahead and try these 3 problems, and when you come back, we'll do it together. Okay, we're back. Cosine theta is defined to be the side opposite theta, or excuse me, the side adjacent theta divided by the hypotenuse. And tangent theta is defined to be the side opposite theta divided by the side that's adjacent to theta. And sine alpha, now we're changing to a different angle. Sine alpha is the opposite side of alpha divided by the hypotenuse. So if you got those right, excellent. So go ahead and try this problem here, and when you come back, we'll do it together. Okay, we're back. So cosine alpha is defined to be the side adjacent to alpha, which is 3 root 5, over the hypotenuse. So if you got that one right, good. Let's try these next problems together. Cotangent theta is defined to be the side adjacent to theta divided by the side that is opposite theta. And we have to multiply both sides of that fraction by root 5. And we get the following ratio. Cosecant theta is defined to be the hypotenuse divided by the side opposite theta, which is 3 root 5. We have to multiply both sides by root 5, and we get the following ratio. Again, I'm doing a lot of that rationalizing in my head. You should be pretty well versed in this type of conversion based on your your intermediate algebra curriculum. And we also reviewed that a little bit in the previous part of this class. Secant theta is defined to be the hypotenuse divided by the side that's adjacent to theta. Go ahead and try the last 4 problems. I'm going to bring down our functions. Go ahead and attempt those green problems, and when you come back, we'll do them together. Okay, we're back. So tangent alpha is defined to be the side opposite alpha divided by the side that's adjacent to alpha. If we rationalize the denominator, we get 2 root 5 over 15. So I multiply both sides of the fraction by root 5. Cosecant alpha is defined to be the hypotenuse divided by the side opposite alpha. Secant alpha is defined to be the hypotenuse divided by the side adjacent to alpha. Multiply both sides by root 5, and we get the following ratio. Cotangent alpha is defined to be the side adjacent alpha divided by the side opposite alpha. So if you got those right, excellent. Okay, so now the angles in the triangles, or the angle measures, are actually given, the actual values themselves. In the first problems that we did, the angles were named by the corners of the triangle, the vertices, but we didn't actually know what the angles were. In this case, we do know what the angles are, but they're given letters. We don't really know the actual numerical values themselves. But now we actually know the angle measures. So in these problems, they want us to find sine of the angle 39 degrees. Sine 39 degrees is opposite divided by hypotenuse. So the opposite side of the angle 39 is y, and the hypotenuse is r. So as you can see, it's pretty easy. Same thing we were doing before. Cosine 39 is the side adjacent to 39 divided by the hypotenuse. Tangent 39 is the side opposite the 39 degree angle divided by the adjacent side. And sine 51, now we're changing the angle. We're going to a different angle. Sine 51 degrees is defined to be the side opposite 51 degrees divided by the hypotenuse. Cosine 51 is defined to be the side adjacent to 51 degrees divided by the hypotenuse. Tangent 51 degrees is defined to be the side opposite 51 degrees divided by the side adjacent. Cosecant 39 degrees is defined to be the hypotenuse divided by the side that is opposite 39 degrees. So that's r over y. Let me write that a little better. And secant 39 degrees is defined to be the side, it's defined to be the hypotenuse divided by the side that is adjacent to 39 degrees. Cotangent 39 degrees is defined to be the side adjacent to 39 divided by the side opposite. So it's pretty much the same thing that we did before. We have a few more problems to do before we're done with this particular problem. Three more before you try one on your own. Cosecant 51 is defined to be the hypotenuse divided by the side that's opposite 51. Secant 51 is defined to be the hypotenuse divided by the side that is adjacent to 51. And cotangent 51 is defined to be the side adjacent to 51 divided by the side that is opposite to 51. So as you can see, these are pretty easy. I'm going to keep those problems in the window, and I want you to try number 14. And when you come back, we'll do it together. Okay, we're back. Sine 58 is the side opposite 58 divided by the hypotenuse. Cosine 58 is adjacent divided by the hypotenuse. Tangent 58 is opposite divided by adjacent. Sine 32 is defined to be the opposite side divided by the hypotenuse. Cosine 32 is defined to be the side adjacent to 32 divided by the hypotenuse. And tangent 32 is defined to be the side opposite 32 degrees divided by the side that is adjacent to 32 degrees. So if you got those right, excellent. So I want you to try the next 4 problems, and when you come back, we'll do it together. All right, we're back. Cotangent 32 degrees is defined to be the side adjacent 32 divided by the side opposite 32. Cosecant 32 degrees is defined to be the side, it's the hypotenuse divided by the side opposite 32 degrees. Secant 32 is defined to be the hypotenuse divided by the side that's adjacent 32 degrees. And cosecant 58 degrees is defined to be the hypotenuse divided by the side opposite 58 degrees. So if you got those right, excellent. So now try the last 2 problems, and when you come back, we'll do it together. Okay, we're back. Secant 58 degrees is defined to be the hypotenuse divided by the side adjacent 58 degrees. Cotangent 58 degrees is defined to be the side adjacent 58 degrees divided by the side opposite 58 degrees. So if you got those right, perfect. So at this point, you should have a fairly good grasp regarding how these functions work. I've been moving these functions around so that we can remember them. But now we're going to get used to calculating these values with your calculator. So here we have an angle measure 82 degrees, and it says use a calculator to find the values and round to 4 decimal places. So the actual values are going to be we need advanced mathematics to calculate these actual values. So what this means is if you have a triangle, a right triangle, it only works for right triangles. Remember, these ratios, these functions that we've been using today only work for right triangles. If you have a right triangle and one of the acute angles is 82 degrees, well, that immediately tells you what the remaining angle is going to be. It's actually going to be 8 degrees. Doesn't really look that way, but then I just drew a random triangle. And they're asking, what is the ratio of the opposite side in orange and the hypotenuse? So the orange divided by the green is going to be the value that we're looking for. But again, we need advanced mathematics to do that, so we're going to use the calculator. Now, if you have a graphing calculator, you want to push the sine button first, and you might have to push, well, it's probably going to be it's going to be one of the buttons. You might have to push the second button at the upper left before you do that, but then you're going to enter 82, and then you're going to press enter at the bottom right, and that's going to give you the value. If you're using a scientific calculator, I believe it's the same order you're going to push the buttons. But with an iPhone, you're going to enter the number first, 82, then you're going to press sine, and immediately it's going to give you the answer. So we're going to round to 4 decimal places, 0.9903. So I rounded up to 3 because we had a 6. So I'm going to enter 82 in my iPhone and then push the cosine button. And round up. We're rounding up on that problem also. And this is just an approximation because the solutions are irrational. They just go on. They're non-terminating, non-repeating decimals. And now I'm going to enter 82. And again, if you have a graphing calculator, you want to press this tan button first, which means tangent, and then enter 82, and then push the enter button at the bottom right. If you do that, you should get approximately 7.1154. So if you're using an iPhone, you enter 82 first, then push the tan button, and immediately it gives you your answer. So let's try some more of these problems. Now notice that we're not finding the values of cosecant, secant, or cotangent. That's a little bit more complicated. We'll learn how to do that later on. Some of your calculators may have that capability, but most of them probably don't. So if you're using a graphing calculator, push the sine button and then enter 25 and then press enter at the bottom right. If you're using an iPhone, enter 25 and push that sine button, and immediately it'll give you the answer, 0.4226. I'm going to enter 25 on my iPhone and then push cosine, and I get 0.9063. But you really should be using a graphing calculator. I'm cheating a little bit and using my phone, but you really don't want to use your phone. You want to get a graphing calculator if you have access to that. So if you're using a graphing calculator, push the tan button, then enter 25 and press enter at the bottom right, and you should get 0.4663. Okay, so now it's time for you to try. Go ahead and attempt number 17, and when you come back, we'll do it together. All right, we're back. So for this problem, you should have gotten 0.745, whoops, 754.7. So if you got that right, good job. For the next one, we have 0.6561. If you got that right, good job. And tangent 49, you should have 1.1504. So if you got that one right, perfect. Again, if you're using a graphing calculator, you enter this button first, the sine button, then you enter 49, and at the bottom right, push the enter button. Go ahead and try number 18, and when you come back, we'll do it together. Okay, we're back. So for sine 17, you should have 0.2924. And for cosine 17, you should have 0.9563. And for tangent 17, you should have 0.3057. So if you got those answers, perfect. So we were just getting familiar with how to calculate those values using a computer, your iPhone or a scientific calculator or a graphing calculator. And again, if you define this angle, and we know that we're talking about a right triangle, so another angle, we've defined the other angle also as 90 degrees, then the third angle is immediately determined. It's set in stone. Once you have the shape of the triangle, it doesn't really matter how big or small the triangle is. The ratio of the opposite side divided by the hypotenuse is going to be the same. It could be a triangle the size of Texas or a triangle the size of an ant. If you divide the opposite side by the hypotenuse, you're going to get the same ratio. Again, if you have a right triangle, one angle is 90 degrees, and if you define the other angle as 82 degrees, then this angle is then going to have to be 8 degrees, and once the shape is set, then it doesn't matter how big or small the triangle is. When you divide the opposite side by the hypotenuse, you're going to get the same number. Or if you divide the adjacent side by the hypotenuse, you're going to get the same number. If you divide the opposite side by the adjacent, you're going to get the same number. Okay, so now we move on to the last thing we're going to do today. We're going to review special right triangles. If you have a right triangle and one angle is 30, that means that the third angle must be 60. This is called the 30, 60, 90 triangle. And this theorem tells us that if the angles in a right triangle are 30, 60, and 90, well, if it's a right triangle, obviously it's 90, but if you have those angles in a triangle, then if the side opposite 30 is x, then the side opposite 60 is x times root 3, and the longest side, the hypotenuse, is 2 times x. Again, if the side opposite 30 is x, then the side opposite 60 is that number times root 3, and the longest side, the hypotenuse, is double that side length. We also learned the 45, 45, 90 theorem that says that if you have a triangle where one angle is 90, so it's a right triangle, and the two other angles are both 45, then if the side opposite 45 is x, then the other leg of the triangle must also be x, and the hypotenuse must be x times root 2. Whatever that number is, the hypotenuse is going to be that number times root 2. So we learned these theorems in my geometry course, and if you forgot them, that's okay. We're going to review them, and you're going to know these like the back of your hand when we're done with this course. So the important thing that you are probably going to ask is, who cares? I mean, why do we care about these? Well, the reason we care is in these special situations, we can actually find the values of the trigonometric functions, these trigonometric functions here, without using a calculator. And it's extremely important that you know how to do that in the trigonometry curriculum. So before I forget, go ahead and take a screenshot of those special right triangles. You're going to need those as we go along today. Now, one really important thing to understand is that it doesn't matter how big or small this triangle is. It could be a triangle the size of the universe, or it could be a triangle the size of an ant. It doesn't make any difference when it comes to the ratios of the side lengths. Once you determine what the angles are going to be, that determines the shape and the ratios of the side lengths. So if you have a 30, 60, 90 triangle, it doesn't matter if that triangle is the size of a car or the size of a millipede. It doesn't make any difference. These values are going to be the same no matter what, because the shape of the triangle is going to be the same, whether it's a very large triangle or a very small triangle. So that's why we have x's here. You're probably thinking, why do we have these x's here? The x's basically mean that the triangle can be as big as you want or as small as you want. We could make x a billion, then this would be 2 billion, and this would be 1 billion, and this would be a billion times root 3. But sine, cosine, tangent, cotangent, cosecant, and secant, they're all going to be the same value regardless of how big the triangle is. I could choose x to be 1 micrometer. So this would be 1 micrometer long. This would be 2 micrometers long, and this would be root 3 micrometers long. But the ratios, the sine, cosine, cotangent, tangent, cosecant, and secant values are going to be the same, regardless of how big or small the triangle is. So, again, once you determine the shape of the triangle, which is decided by the angles in the triangle, the ratios themselves don't change. So that's why we have written these sides as multiples of x. It doesn't matter how big the triangle is. So sine 60 is the side opposite the 60-degree angle divided by the hypotenuse. And it doesn't matter what x is. You could plug a very big number in for x or a very small number. X is going to cancel out. That proves that it doesn't matter how big or small the triangle is. So we calculated that value without using a computer. Cosine 60 is the side adjacent 60 divided by the hypotenuse. X's cancel out, and you're left with 1/2. Tangent 30 is the side opposite the 30-degree angle divided by the side adjacent the 30-degree angle. The x's cancel out, and you're left with 1 over root 3. Multiply both sides by root 3, and you end up with root 3 over 3. Cosecant 30 degrees is defined to be the hypotenuse divided by the side opposite 30 degrees. So that's going to be 2x divided by the side opposite 30. X's cancel out, and you're left with 2 over 1, which is just 2. Sorry about the sloppy writing there. Secant 60 is the hypotenuse divided by the side adjacent to 60. So that's going to be 2 over 1 also, which again is just 2. Cotangent 30 is the side adjacent 30 degrees divided by the side opposite 30 degrees. The x's cancel out. You're left with root 3 over 1, which is just root 3. Alright, so now it's time for you to try. Again, we're doing these special 30, 60, 90 degree triangles. Go ahead and attempt these first 4 problems, and when you come back, we'll do them together. Okay, we're back. Sine 30 is the side opposite 30 divided by the hypotenuse. X's cancel out, and you're left with 1/2. Cosine 30 degrees is the side adjacent 30 degrees divided by the hypotenuse. X's cancel out, and you're left with root 3 over 2. Tangent 60 degrees is the side opposite 60 divided by the adjacent side to 60. X's cancel out, you're left with root 3 over 1, which is root 3. Cosecant 60 is the hypotenuse divided by the side opposite the 60 degree angle, and x's cancel out, you're left with 2 over root 3, but we have to rationalize that denominator, so we're going to multiply both sides of the fraction by root 3, and we get 2 root 3 over 3. So if you got that one right, good job. Okay, go ahead and try secant 30 and cotangent 60, and when you come back we'll do it together. Okay, we're back. Secant 30 degrees is defined to be the hypotenuse divided by the side adjacent 30 degrees. X's cancel out, and you're left with 2 over root 3. Multiply both sides by root 3, and we get the following ratio. If you got that one right, good job. Cotangent 60 degrees is defined to be the adjacent side of 60 divided by the opposite side. X's cancel out, you're left with 1 over root 3. But we have to rationalize the denominator, multiply both sides by root 3, and we get root 3 over 3. So if you got that right, perfect. Okay, so we have one more problem. Now we're going to move to the 45, 45, 90 triangle. It doesn't matter how small or how big the triangle is. If you have two angles that are 45 degrees and a 90 degree angle, then whatever this side is, this green side or the red side is going to be the same as the yellow side, and the hypotenuse is going to be whatever that length is times root 2. So sine is defined to be the opposite side of 45. Now notice that there's two 45 degree angles, so which one do we use? Well, it doesn't matter. You're going to get the same answer either way. So I'm just going to use this one down here. So the opposite side of 45 is x, and the hypotenuse is x root 2. X's cancel out, you're left with 1 over root 2. Multiply both sides by root 2 and you get root 2 over 2. Cosine 45, why don't you go ahead and try cosine 45, and when you come back we'll do it together. Okay, we're back. So we get x over x root 2. The x's cancel out, and you probably noticed that we got the exact same answer. So if you got that, good job. Let's do tangent 45 together. The side opposite 45, and I'm using this angle, it doesn't really matter which one of these 45s are used, but side opposite divided by the adjacent side, which is also x. X divided by x is 1 over 1, but you don't even really need to write that intermediate step. I don't know if that really helps. You can just go straight from here to here, that's fine. So why don't you try the next problem, cosecant 45, and when you come back, we'll do it together. All right, we're back. Cosecant is defined as the hypotenuse divided by the opposite side. Now, if you're using this angle, the opposite side is x, but if you're using this angle, the opposite side is also x. It doesn't really matter. You're going to get the same answer. So that simplifies to root 2 over 1, which is simply root 2. So if you got that one right, excellent. Okay, why don't you try the last two problems, and when you come back, we'll do them together. All right, we're back. Secant 45 is the hypotenuse of the triangle divided by the side adjacent. So if you're using this angle, the side adjacent would be x, but again, you're going to get the same answer. So your final answer should be root 2. And cotangent 45 is defined to be the adjacent side of 45, which again, it just depends on which 45 you're using. You're going to get the same answer. The adjacent side divided by the opposite side, and you get 1. So if you got that right, excellent. So that was the class today. If you'd like to take screenshots of all the work that we did to help you with your homework, go ahead and do that now. Here's screenshot number 1. And number 2. Number 3. Number 4. Number 5. 6. 7. 8. 9. And 10, but don't go before you get your homework. Let's take a look at the homework. Here's screenshot number 1. And number 2. And here's the answers for problems 5 through 14. And the last screenshot. So be sure to get that homework done completely, correctly, and neatly, and keep it in order in your binder. And I'll look forward to seeing you in the next class.